In this video, we're going to learn about the midpoint theorem for a triangle. So let's go ahead and state it. The midpoint theorem states that the segment joining the midpoints of two sides of a triangle, first of all, is parallel to the third side, and second of all, has length equal to half the length of the third side. Okay, so let's go ahead and process this. What does this actually mean visually? Well, we've got a triangle right over here, and we've got the midpoints of both sides labeled, and they are connected by this red line here. So this red line is the segment joining the midpoints of the two sides of the triangle. And the midpoint theorem is saying, first of all, that this segment here is parallel to the third side in blue here. So let's go ahead and make arrows on the lines to show that they're parallel. And then second of all, it has length equal to half the length of the third side. So if the third side has length, say, L, then the segment joining the midpoints of the two sides has to have length L over 2. Alright, so now that we know the theorem, let's go ahead and solve for the unknown variables in the diagrams below. First of all, in this diagram, we're solving for x. X is the segment joining the midpoints of the two sides of this triangle, and the third side, of course, is 8. Okay, well, according to the midpoint theorem, we know that the segment joining the midpoints of the two sides of the triangle, in this case, x, has length equal to half the length of the third side. So x is just half of 8. So 8 divided by 2, which is 4. So there we go. X is equal to 4. Alright, and then in this diagram here, we want to solve for y. Y is the third side, and we know that the segment joining the midpoints of the two sides of the triangle has length 6. Why don't we go ahead and set up the same kind of equation? So the segment joining the midpoints of the two sides of the triangle, that has length 6 here, and that is equal to the length of the third side, y, divided by 2. So now we can just go ahead and solve for y here. We'll go ahead and multiply both sides by 2 to get 12 equals y. So there we go. That's all there is. Y is 12. Alright, next question. We're given that the perimeter of triangle ADE is 18, and we want to know what is the perimeter of triangle ABC. Alright, so why don't we state this in terms of the sides of the triangle. The perimeter of triangle ADE is 18, and triangle ADE is right here. That's composed of sides AD, and then DE, and also AE. So AD plus DE plus AE, those side lengths have to sum to 18. Okay, so that's the part of the question that says the perimeter of triangle ADE is 18. Now let's also translate the part that says what is the perimeter of triangle ABC. So the perimeter of triangle ABC is equal to the sum of the sides. So AB, BC, and AC. So let's write that out. AB plus BC plus AC. So let's see if we can get these sides, AB, BC, and AC, in terms of these sides which we know a bit about, AD, DE, and AE. We see, first of all, that AB is twice the length of AD. D is just a midpoint of the segment, AB. So AB can be written as 2AD. we also see that AC here can be written as 2AE. And then since D and E are midpoints of these two sides of the triangle, we know that the segment connecting these two midpoints has to have length a half of the length of the third side, BC. So that means BC, this length there, is equal to 2DE. And we can go ahead and write that in. BC is 2DE. So let's go ahead and factor out a 2 out of this expression. So 2 times AD plus DE plus AE. And hey, we know right here that AD plus DE plus AE is 18. So let's go ahead and substitute that in. So this is equal to 2 times 18, which is equal to 36. So there we go. That's the perimeter of triangle ABC, 36. Alright, so now we've got some more questions. Again, we want to solve for some unknown variables in the diagrams below. So in this diagram, we want to solve for the angle measure x, and we know that this angle here is 35 degrees. So how do we do this? Well, let's think back to the statement of the midpoint theorem up here. We've already done some problems where we've used the fact that the segment joining the midpoints of the two sides of the triangle has length equal to half the length of the third side. But the midpoint theorem also states that the segment is parallel to the third side. So this segment here, joining the midpoints, is parallel to that third side of the triangle. So that means this side of the triangle right here is actually a transversal that cuts through those two parallel lines. Let's go ahead and elongate the parallel lines just to illustrate this very explicitly. So we can make the parallel lines a little bit longer in this direction towards the left. And then we see very clearly that this third side here of the triangle actually cuts through those two parallel lines as a transversal. And that also makes it very clear that we have some corresponding angles there. X and 35 degrees, these are corresponding angles. And corresponding angles, we know that those are congruent. They have the same measure. So X is just equal to 35. Alright, so moving on to the next diagram. In this diagram, we want to solve for y. And again, we know that the segment joining the midpoints of the two sides of the triangle is parallel to this third side of the triangle. So that means this left side of the triangle is actually a transversal cutting through a pair of parallel lines. So can we use the same argument? This angle y has a corresponding angle that's right here. And do we know the measure of that angle? No, unfortunately we don't. But hey, can we find it? We've got two angle measures in this triangle, and the triangle has to sum to 180 degrees. So why don't we just go ahead and subtract these two angle measures from 180 degrees, and that'll give us the angle which has the same measure as y. So y is equal to 180 minus 80 minus 40. Let's go ahead and simplify that. 180 minus 80 is 100, and then 100 minus 40 is 60. So y equals 60. Lastly, let's go ahead and prove the midpoint theorem, which is to say, for this triangle here, we want to show that the length DE is half the length of BC, and also that DE is parallel to BC. Alright, why don't we tackle this part first about DE being half the length of BC. This really just results from triangle similarity. So first we'll prove that this small triangle here and this large triangle here are similar. So we'll write that triangle ADE and triangle ABC have two pairs of corresponding sides which share the same ratio. Namely, we have AB over AD and also AC over AE. These ratios are both equal to 2. And that's because AB is twice the length of AD and AC is twice the length of AE. And also, these pairs of corresponding sides share the same angle A between them. Angle A is between AB and AC. Also, angle A is between AD and AE. So we have that triangle ADE is similar to triangle ABC by side angle side. Thus, as a consequence, the third pair of corresponding sides must have the same ratio. In other words, we have that BC over DE equals 2. And that can be rearranged to say that BC equals 2DE, which can also be rearranged to say that BC over 2 is equal to DE. And that's what we wanted to prove in the first place. Good, so we've got that part there. We've got that DE equals BC over 2. And now let's go ahead and prove the part about DE being parallel to BC. And this fact about similar triangles is going to help us a lot. So because triangle ADE is similar to triangle ABC, we must also have that corresponding angles share the same measure. And angle D is corresponding to angle B, so we need measure of angle D is equal to measure of angle B. These two angles here. And again, that's because these two triangles, triangle ADE and triangle ABC, are similar. So now we can say that interpreting DE and BC as a pair of lines, let's go ahead and draw a little bit through them to make this very clear. Interpreting these as a pair of lines and another line, AB, going through them, by the converse corresponding angles theorem, because angle D and angle B are corresponding angles and they have the same measure, we conclude that the transversals here must be parallel. So we conclude that DE is parallel to BC. These two transversals must be parallel. So there we go. There is the second part of what we wanted to prove, and then we are done. So now we know how to prove and use the midpoint theorem for a triangle. And in the future, we'll continue to learn more theorems about triangles, such as the proportionality theorem.